Okay, my 5.4 accidentally got deleted, and these are just sort of solving for x and in rational equations. Now, there's two ways to prove that x minus x is equal to 3 and x is equal to minus 2 is a solution to this, is you can just sub them in. But the problem with just subbing in is, yes, you've proven that those two solutions are the answer, but maybe there's other solutions as well. So notice there's a 3 as a denominator and an x as a denominator, so we're going to multiply both sides by 3 and x. Of course, right here on the left side, 3 times x times 2 over x, these x's will cancel out. And you're left with 3 times 2, which is 6. On the right side, when I multiply by 3 times x, it's multiplying x minus 1 over 3. And in this case, the 3's cancel out. So you're left with x times x minus 1, which is x squared minus x. It's clear we're going to be left with a parabola or a quadratic, so we subtract 6 from both sides. And when it's equaling 0, and only when it's equaling 0, we can solve it. And we discover x minus 3, x minus 2, and therefore the possible solutions, x minus 3, x plus 2. Therefore, the possible solutions when we solve individually are x is equal to 3 or x is equal to minus 2, and those are the only two possible solutions. So substitution is great to prove that you have the right answer, but algebra is how you actually prove that those are the only two answers. Do the same with this. They want us to do it with verifying graphing technology after you solve it. What's interesting about this is when I multiply both sides by the denominator, which should be in brackets, when I multiply both sides by this and this, they cancel out on both sides. That's because these cancel out here. And x minus 1 times 0, always 0. So you're left with this, and the only possible solution is x is equal to minus 3. Then you can throw it on graphing calculation and discover that, yeah, there's going to be a vertical asymptote at x is equal to 1. And then way over here at x is equal to 3 is the only possible, it's the only place that it will cross the y or the x-axis where y is 0. That's essentially what you're proving when you make it equal to 0, is where does it cross the x-axis when y is 0. So in that case, you're going to see a reciprocal function like that with an asymptote at x is equal to 1, and then right over here at x is equal to minus 3, it's going to be minus 3 comma 0. It'll cross the x-axis there at that point, and only at that point. That's what happens when you make anything equal to 0. You're finding out when it crosses the x-axis. All right, so this case we have to multiply both sides by the denominator, here on the left and here on the right. On the left, it's going to eliminate. That's why we do it. On the right, we're left with 2 times x minus 1. Try to remember that that's in brackets, because the 2 must multiply through both of that. And you're left with 2x minus 2. And then when we bring all this x to the other side, we get 1x. And when we bring this 3 to the other side, we get minus 5. Therefore, x is equal to 5. And how do you prove it? Well, they want you to go in the graphing calculator, and you can prove it then. Or you can just substitute it in here. When we put in 5 up here on the left side, we get 8. When we put 5 in here, we get 5 minus 1, which is 4, times 2, which is 8. 8 right side, 8 left side proves it's true. Continuing, we have a denominator of x minus 1 again. So we're going to multiply both sides by x minus 1. And of course, it crosses out, eliminates here, which is why we did it. And here we're going to have a parabola. Try to remember it's in brackets. So you get x plus 3 is equal. And so we got to expand this. 2x squared minus 2x plus x minus 1. Minus 2x plus x makes minus x. And then when we bring this x over here, we get minus 2x again. And when we bring this minus 3, if there's 3 over by subtracting 3 on both sides, we get minus 4. So we're left with 2x squared minus 2x minus 4, which means we're looking for a number that multiplies out to minus 8 that adds up to minus 2. In this case, we're looking at minus 4 and plus 2. That multiplies out to minus 8 and adds up to minus 2. You can do the slip and slide method, although I don't particularly like it in this case, where you just put this in brackets and then you divide by 2. But the problem here is it won't quite work perfectly. So in this case, you would just put the 2 here. In this case, when this is divided by 2, you get that. And then when you just solve it, and the reason I have to put the 2 here instead of dividing it into 2 is because otherwise we would not get a 2x squared. And when I expand it, 2x squared plus 2x minus 4x gives me minus 2x and then minus 4. So that's the solution there, which means that x is equal to 2. Oh, it all has to equal 0, by the way, which means that x is either equal to 2 or 2x is equal to minus 2 or x is equal to minus 1. And then you can put it in the graphing calculator and you'll discover that this thing crosses the x-axis at 2, 0 and minus 1, 0. Or you could substitute it into the original equation and solve, and you'll discover your answers will work on left side, right side. And this is how they're solved over and over and over again. In this case, we have 2 denominators. And you can look at it as multiplying both sides by the denominators. But notice if you do that, every time, if I multiply both sides by 5x and 3x plus 2, that works. But I want you to look what happens when I do that. When I do that, this 5x disappears, so I'm just left with 3x plus 2. And this 3x plus 2 disappears, and I'm just left with 5x. So an easier way is just to realize that what you're doing is cross multiplying. This goes here, this goes here, and everything at the bottom disappears. So when I do 5x times 3, I get 15x. When I do 6 times 3x plus 2, I get 18x plus 12. When I bring the 15x over to the right side, it gets 0 and becomes 3x. When I solve for x, I get 3x is equal to minus 12, or x is equal to minus 4. If I put that back into the original solution, I should get the right answer. Now, I don't know what they mean by where zeros are the solution, but I think they just mean solve and make it equal to 0, which is what I've been doing anyway. So we have to multiply both right and left by this, and notice it always disappears on the left side. So I have to multiply that bracket by 2. I get x minus 3 is equal to 2x plus 6. When I solve for x, when I move it all to the right side, which is what they mean by solving for 0, I get this, which means x is equal to minus 9. So I do it the same for this one. And it just cross multiplies, the easiest way to do it. And get rid of the bottom. So I get that left side bracket multiplied by 2, I get 6x minus 2. And the right side is 5x. Now if I put the 5x to the other side, so I subtract 5x from both sides, I get x minus 2 is equal to 0. That's what solving for 0 means. And I discover that x must be equal to 2. And that's how you do all of these. Not complicated. So again, we're going to cross multiply. Get rid of the line. The right side's an easy multiplication. The left side is 2 brackets times each other. I get x squared minus x plus 3x minus 3 is equal to x squared plus x. Notice that when I subtract x squared from both sides, the x squareds disappear. When I subtract x from the right side, I get minus 2x on this side, and this is 0. When I take minus 2x plus 3x, I get x. So x is equal to 3. And then you substitute it back into the original equation to verify, or put it in the graphing calculator to see. Use Desmos for that. So again, we're going to cross multiply. When I multiply the left bracket, I get x squared minus 2x plus 5x minus 10 is equal to x squared plus 3x minus 4x minus 12. This minus 2x plus 5x becomes plus 3x, and this plus 3x minus 4x becomes minus x. Notice when I subtract x squared from both sides, I'm left with 3x minus 10. Well, let's just use what's up there. When I subtract x squared from both sides, this disappears, and this disappears. When I add x to both sides, this becomes 4x. When I add 10 to both sides, this becomes minus 2. And I get x is equal to minus 2 over 4, which is equal to negative 1 over 2. Then you plug it in to make sure that that's the solution. Then it's much the same over and over again. They just want you to solve. And it's the same method. I mean, I don't think I'll solve it here, but I will point out interesting examples. These have 3 denominators. So you just multiply both sides by all of them. So 3 times x on the left side, and 3 times x on the right side. On the right side, it's clear that one of the x's will disappear. And on the left side, you have to distribute it. So it's going to be 3 times x times this, and 3 times x times that, with the plus in between them. It's clear over here that one of the x's cancels out, and it's clear over here that 3's cancel out. So 2 times 3 times x on the left here is 6x. 5 times x is 5x squared. 7 times 3x is 21x. When I take that 21x and bring it to the other side, I get 5x squared minus 15x is equal to 0. When I take an x out of that, I get 5x minus 15 is equal to 0, which means x is equal to 0. You solve for both of them individually, or 5x minus 15 is equal to 0. Add 15 to both sides. Divide by 5 both sides. X is equal to 3. So there's the 2 possible solutions. Now what you're going to discover is when the x squareds don't disappear, when there's an x squared left, you're always going to have 2 solutions, because think about parabola. It passes through the x-axis twice, so there's going to be 2 spots where y is 0, which is what you're doing when you make something equal 0. You're finding out when it crosses the x-axis. These are all going to be the same method. It's not that confusing when you practice it for a while. So if you look at the denominators, there's only a 3 and a 3x. So that means I'm going to multiply both sides by 3 times 3x, plus x plus 3 times the rest of it. And I'm going to do that on both sides. Over here, it gets distributed through, and it multiplies this, and it multiplies, move the plus over, and it multiplies that. And you can see various things cancel out. The x plus 3 cancels out on this side, and the 3 cancels out on this side. Now the whole point is to get rid of denominators. That's the whole point. So we got 3 times 10, which is 30, plus 10 times x plus 3, which is 10x plus 30, is equal to 18 times x plus 3, which is 18x, plus 48, 44, no, 36, 44, 54, 54. Yeah. When I get all my x's on the same side, I discover, let's put them all on the right side. So I got 10x plus 60 is equal to 18x plus 54. And the reason I put it on the right side is to keep everything positive. So I'm going to subtract 10x from both sides. And I'm going to subtract 60 from both sides. And I get that. So that means 8x is equal to 6, or x is equal to 6 divided by 8, which is equal to 3 over 4. Then you plug it back into your original equation to prove it. So it looks like all of these are sort of double denominator questions, or just trying to get used how to get rid of multiple denominators. In this case, the only denominator is x minus 3. So that's the only thing we have to multiply on both sides. Now the nice thing is, it's going to cancel. Except on this right side, while this left side, it's going to cancel easily. On this left side, it still has to multiply through to both of these things. Both of these things are in brackets, which means it's going to multiply by 1 and make x minus 3. And the other one, it's going to cancel out. You're going to be left with x, with 6, right? And let's just make sure what was in between them, minus 6. So, and there we go. This times 1 is just that. Up here, it's clear x minus 3 is going to cancel with this. So you're left with 2x is equal to x minus 9. When you bring it all to this side, it's x is equal to minus 9. Or when you bring the x over. So that's the solution to that one. Oh, looks like I accidentally deleted. Yeah, I accidentally deleted D. So let's go get a picture of it again. Yeah, I deleted a lot of D, E, and F. There we go. So this one's interesting. The only denominator is x plus 1, but it's got to distribute through. So I'm going to do this. When I multiply x plus 1 times everything, I get that. And I might as well put it there. And on the right side, like that. Here, it's clear it cancels into 1. And here, it's clear it cancels into 2. And over here, when I distribute it, so 2 plus 1 is 3. When I distribute, I get 3x plus 3. When I subtract 3 from both sides, I get 3x is equal to 0. Therefore, x is equal to 0. It's the only possible solution. And when you plug it back in, that's true. This one, we have 2 different denominators on the fraction, which actually makes it easier, because all you have to do is cross multiply. So I get 8 minus 2x is equal to 10x plus 5. And then when I put the 2x on the right side, I get 8 is equal to 12x plus 5. And I get subtract 3 from both sides. Hello.
Good afternoon. My name is Mel from Choice.
Okay, continuing on for the last one, I think. And same thing, we've got a cross multiplication going on. Like that. When I multiply x plus 3 times 5, I get 5x plus 15 is equal to 4x minus 8. And when I get the x to one side and the 15 to the other side, I get x is equal to minus 23. So that's the only possible solution. So that's number 5. Number 6, you do the same. Number 7, you do the same. It just gets a little trickier. Okay, so it's much the same here. We cross multiply. This is 6a, by the way. And of course, the bottoms will disappear. When I multiply 2x times 4 minus x, I get 8x minus 2x squared. And on the right side, when I multiply 5 through, I get 10x plus 5. I'm going to bring everything to the right side instead. I'm going to get the right side 2x squared plus 2x plus 5 is equal to 0. Hang on. Yeah, this should be 8x. 8x minus 2x squared. Yeah. Bring that over. I get 2x squared plus 2x plus 5. Yeah. So I'm looking for a number that multiplies out to 10 and adds up to 2. So it can't really work. Yeah. You can't really solve that in your head. 5 and 2 doesn't work. So you have to go to a quadratic equation where your a is 2, your b is 2, and your c is 5. So I'm super lazy. I use the quadratic formula calculator. And as we can see from these i's down here, there's no possible solution. So I might go back and verify my questions or my algebra to make sure, but I'm pretty sure I got it right. Sometimes there are no solutions. For instance, a parabola can be above the x-axis or the y-axis and there'd be no solution. So we're looking at b now. If I multiply everything by the denominators are x and x plus 1. So I'm going to multiply both sides by x and x plus 1. And if I multiply left side of an equation, I have to multiply right to keep it balanced. And instantly they're multiplying through to each thing. And we can see that for the first one, the x is canceled. And for the second one, the x plus 1 cancels. So you're left with 3 times x plus 1, which is 3x plus 1, or 3x plus 3, plus 4x is equal to x times x plus 1 is x squared. So it's, well, let's do 2x times x plus 1. So you get 2x squared plus 2x, which means we're dealing with parabola. Let's get it all to the right side because the 2x squared is positive there. Put the, over here we've got 4x plus 3x, which is 7x. When I bring that 7x over to the other side, it becomes minus 5x minus 3 is equal to 0. So we're looking for something that multiplies out to minus 6 but adds up to minus 5. So we're talking about 9 at minus 6 plus 1. I can use the slip and slide method. What it is I just put those factors in like this. Then I take the original number in front of the x squared, which is 2, and I divide both of them by 2. 6, whatever can divide easily. 6 minus 6 divided by 2 is indeed minus 3. But this 1 divided by 2 can't form a whole number, so I instead slide the 2 in front, and now I get my possible factors, which means that x is equal to 3 or x is equal to negative 1 over 2. The slip and slide method is a cheating method instead of grouping them. It's faster. It's not always foolproof, so you have to verify your answer a bit, but it's much faster. So here we're talking about 5. Now what's nice about this is really I only have to multiply both sides by 5x. And on the right side it's going to cancel. And over here the 5 is going to cancel. So I'm going to be left with x times 2x, which is 2x squared. And on the right I'm left with x squared minus 5x. Let's bring it all to the left side. I get x squared plus 5x is equal to 0. Let's factor an x out. I'm left with x plus 5 is equal to 0. So that means x is equal to 0 or x is equal to minus 5. And that's my two possible answers. Moving on to D. Oh, it looks like I cut off D, so I'll have to go back and get it. There we go. Moving on to D. We've got this. And I'll just get rid of my clutter here. So I'll have to multiply both sides by x minus 2. When x minus 2 multiplies through to both fractions, I get this. I'm going to have to multiply both sides. It's clear 0 times x minus 2 on the right is just 0. And it's clear that these just cancel out. So I'm left with x times x minus 2, which is x squared minus 2x plus x is equal to 0. Minus 2x plus x is simply minus x. Factor an x out, I get x times x minus 1 is equal to 0. Therefore, x is equal to 0 or x is equal to 1 are my two possible answers. And it's the same thing over and over again. In this case, I have two denominators, so I have to multiply both sides by both denominators. I have to multiply this and this times the individual fractions on the left, and this times 13 on the right. Very quickly, it's clear that these will cancel out, and it's clear that x plus 3 is left over. So x plus 3 times 1 will just be that. And then on the right fraction, when I multiply by this, it's clear that the x plus 3's will cancel out. And I'm left with 24 times x plus 2. So on the left, I'm left with x plus 3 plus 24x plus 48. And then before I do the 13, I'm just going to expand x plus 3 times x plus 2. I get x squared plus 5x plus 6. And then when I multiply the 13 through, I get 13x squared times 65x plus 60 and 8, 78. And then if I add all my x's here, I get 25x. And if I add my 3, I get 51. And I'm left with that. If I get it all to the right side, I get 13x squared plus 40x plus 57 is equal to 0. And so and I'm too lazy. I'm just going to use the quadratic. I think there is a solution here actually, but just use the quadratic. It's faster and gives you the same answer. So that's my A, B, C. So I got to plug it in. A is 13, B is 40, and C is 57. Oop, I did a small error on the 57. This 51 subtracting from 78 is 27. So plugging that in and hitting calculation. I get this. And there's two possible solutions. And these are the possible solutions. X is equal to minus 1 or x is equal to minus 27 over 13. And you probably want whole answers unless they ask you to round up. You should always give it as fractions, which are more accurate. And let's see, what's the last one? Or of 6 anyway. It's this. Get rid of the clutter. Multiply both sides or just cross multiply. That's the easiest thing when there's just one fraction on each side. So on the left side I get minus 2x minus 2 is equal to x squared minus x minus 8x, which is minus 9x, minus plus 8. Then when I get everything to the right side, I get x squared minus 7x plus 10. So I'm looking for a number that multiplies out to 10 but adds up to negative 7, so that's hard to do. So we just do x, a is equal to 1, b is equal to negative 7, c is equal to 10, assuming I got all my numbers right. Feels like I might have gotten this one wrong. Minus 7, so I punch that into my quadratic calculator. And I get x is equal to 5, or x is equal to 2. So, oh yeah, that's stupid. Why couldn't I solve that? Idiot. So, those are the factors. Boy, my brain farted there. Anyway, I'll move on to 7 in a second. Now in number 7, notice it says round to 2 decimal points, which means almost all your questions are going to involve using the quadratic formula if they're implying that we have to round up. But the methods are still the same. So when it's two fractions, we just cross multiply. And this one shouldn't anyway. And then when we, oh, I didn't cross multiply properly. So this goes to the other side, that, and this goes to that side, like that. So when I multiply on the left side, I get 2x plus 12. And on the right side, I get 3x plus 6. If I put everything on the right side, I get x minus, well, actually, let's just put the x's on the right side. If I put 6, subtract 6 from both sides, I get that. If I subtract x from both sides, 2x from both sides, I get that, which means the answer for the first one is x is equal to 6. And when you plug it in, you do indeed get the proper response. So this one, because there's 3 separate denominators, even though it's d, I have to multiply everything. So I'll just separate these fractions like this. I have to multiply by everything by 45. Whoopsies. 45 times x times 2x minus 3. And when I multiply 1, that's what I get. Notice that the x cancels out here, so I get 2x minus 3 times 45. And, oh, let's bring that all back so that I have it all like this. So it essentially multiplies by 1, it's going to be this, and by 1, it's going to be this, and by 1, it's going to be this on the right side. Notice the 45 cancels here, the x cancels here, and the 2x minus 3 cancels on the right side. So just ignore that. Yeah, 2x minus 3. So that means I'm going to get 45 times 2x minus 3, which is 90x minus 135. And then there's going to be a minus 2x squared minus 3x, which is going to become a minus 2x squared plus 3x when that minus goes through it. And then on the right side, we just have, we're going to have 45 times 45x. And that's what we have. Now we're going to get all the x squareds. Let's get them all to the right side. So we're going to have on the right side, let's add these 3 x's actually. So 93x. Actually, let's just do it like this. We're going to add, we're going to leave the x squared on this side. So we get minus 2x squared plus 90x plus 3x minus 45x minus 135 is equal to 0. And so I get minus 2x plus 9 minus 45, 48x here, plus 48x, minus 135. If I divide everything by -1, I get this. And now I can put that into my quadratic formula, where a is 2, b is minus 48, and c is 135. And these are the 2 possible answers I get. Right there. And they want it to 2 decimals. So if I look here, this 4 has to round up to a 5. And this 5 down here doesn't round up at all. So there's my 2 possible answers when I use the quadratic formula, assuming I got the calculations right. So they're all like this. They're all like this. So b, we can just cross multiply. Goes up like that. This goes over like this. And you're going to get a quadratic. It's going to be 8 squared, 2x squared rather, minus 5x minus 12x plus 30 is equal to x plus 10. When you get it all to the same side, you get 2x squared minus 6x, and minus 12x minus 18x plus 20. So we're talking about something that multiplies out to 40 and adds up to minus 18. So it's going to be two negative numbers like, see if I get the minus 18 right. Yep. So it's going to be like 4 and 10. That's a tough one, so I'm just going to put it in the quadratic. So 2 for A, minus 18 for B. And for C, I have, let's see, plus 40, plus 20, so 20. And when I calculate, I get some decimals like this. Like that. Those are my two possible answers. And you got to round up to the two decimals. And that means this one becomes 1.30. And they're all like that. So there you go. I'll keep going in a second. Okay, almost done. So now we've got 8. Now 8, verify, use algebra to solve. I don't know why they give 8 as separate. It's pretty much the same question. So we'll copy 8, 9, and 10. Like that. I'll go crop. And here's 8. Essentially 8 says solve this. And I'm not sure why it's written as a set. Explain your steps and verify your answers using the graphing calculator. I'll let you use the graphing calculator. But this is just a cross multiplication. Okay. But probably the secret here is there's going to be a little snafu or x squared is going to disappear or something. But if I multiply out the two brackets on the left here, I get x squared. And let's make this a little bit bigger. X squared plus x minus 4x minus 4. And so plus x minus 4x, of course, gives us minus 3x. And on the right side, we get x squared minus 2x plus 3x minus 6. And so, of course, minus 2x plus 3x makes plus x minus 6. So then if I get my subtract, yes, sorry, it should be minus 2x plus should be a plus here. And then if I subtract x squared from both sides, it's clear the x squareds disappear. So that's probably what they're going on about. Then if let's just add 3x to both sides and add 6 to both sides. So I get 2 on the right side, and I get 4x on this side, which makes x is equal to a half. Now I'm sure if you put that into the equation, you'll get that answer. I suspect maybe there's a hidden answer in somewhere. They want us to verify the answer using substitution. I don't know if I'll do that. Minus 1. Yeah, it becomes minus 1 and equals minus 1, so that works. Maybe there's a hidden one, but no, I don't know what the deal is with that one. It's not that hard. This one does the golden triangle, but then he says what happens when width is 15, so it's kind of pointless. So here's the golden triangle formula. Then they go and say, what happens when width is 15? Well, okay, well, or length is 15, rather. Okay, well, wherever I see length, I'm going to put in 15. And then you just have to cross multiply like every other problem we've done. And we're probably going to get a quadratic. So on the left side, we get 15 times 15, which is 225, minus 15w. And on the right side, we got w squared. So putting everything on the right side, we get w squared plus 15w minus 225. Now, I have no doubt that I can come up with something that adds up to 15 and multiplies out to minus 25, except I'm not going to bother. I'm just going to use my quadratic formula calculator. And I'm going to put in for A 1, B minus 15 or plus 15, and C is minus 225, and see what we get. Yeah, sure, we get these two possible answers. And hopefully that's the right answer, unless I did a calculation error. It's really not that complicated. If I did a calculation error, big deal. You should still get the answers. But they're saying the possible answers for W are minus 224 and 9. Now, obviously, you can't have a minus 24 length or width. So you can ignore that, and that's the only possible answer. And then this one has chocolate machines. Machine A takes S minutes to fill the chocolate. Machine B takes S minutes plus 10 to fill it. Working together, the two machines take 15 minutes to fill a case. Okay, well, this is weird, but essentially, the idea is when you're doing productivity, if it takes 1 over S to fill a machine, plus 1 over S, these are proportions of the work, plus 10, like that. That's our productivity. Then you would multiply it by 10. Now it depends if it's 1 over S minutes. Yeah, it is. So you multiply that by 10. And that should equal 1 machine. That should fill 1 machine, or 1 unit of productivity. So if you multiply the 10 through these fractions, you get 10 over S and 10 over S plus 1. Then you have to multiply both sides by S and S plus 10. Now on this side, the S plus 10 is going to eliminate. You're going to just have an S up here. And on this, the S is going to eliminate, and you're going to have an S plus 10. So you're going to get at 10 times S plus 10 plus 10S. And on the right side, you're just going to have S squared plus 10S. That's 10 times this. That's what you're going to have. If we multiply through the left side, I get 10S plus 100 plus 10S. So technically that's 20S is equal to S squared plus 10S. I'm not sure if this is the right answer, by the way. So putting it all on the one right side, I get S squared minus 10S minus 100 equal to 0. So I think I got to put that into the thing. So I got 1 for S, minus 10 for B, 1 for A, minus 10 for B, and minus 100 for C. Let's see if anything comes of that. And yeah, we have 2 possible answers. And 1 is negative. So obviously you can't have negative time. So you can dismiss one of them. And it looks like S is 16 minutes. So that's the solution for S. So that means it takes 16 minutes to fill one case and 26 minutes to fill the other. Not sure if that's the right answer. So we should look into it. And actually, it might have been equal to 2 instead of 1 because we're to fill a case. Oh, no, to fill a case. So I think that's the way to do it. Not sure. The next question, I'm definitely sure that's the way to do it. I'm not going to do, actually the next 3 we'll do, 11, 12, and 13. We'll just start with 11 and 12. Okay, you have a large box, you buy a large box of comics for 300. She gave 15. So let's say the price times X is equal to 300, and X is the number of comic books and P is the price you paid. She removes 15 of them and she sells them for price 2, but she removes 15 of them and she gets 330. But it also tells us the profit. Profit is $1.50, which means price 2 minus price 1, we're going to do price 1 up here, times X, times the number of comics, is equal to $1.50. Which means you can replace one of these as a form of, for instance, price 2 is going to be equal to $1.50 plus price 1. Which means I can replace where I see price 2 with $1.50 plus price 1, like that. Which means I have 2 unknown equations, X and price 1, and two equations. So up here, this is good. We can also replace price 1, we know is equal to 300 divided by X. Right, like that. So now that means everywhere I see price 1 down here, I can replace it with that. I'm just going to get rid of this entirely, this 12. So that means everywhere I see price 1, I can replace it with this. And I only see it there. Now keep in mind that this is in a bracket and has to multiply out this bracket. But it's a lot easier for me to get rid of the x by multiplying both sides by x. And you might think because there's two brackets, I'd have to multiply through both of them. But because these two brackets are multiplying, I indeed only have to multiply it through this one. And the second one, it'll cancel out. And I don't have to multiply it through the second one because these are multiplying brackets. So that means I can now expand it. And I get 1.5x squared minus 22.5x plus 300x minus 15 times that, 300, 450 is equal to 330x. When I bring the x to the left side, well, first of all, I get, if I bring minus 330x, it's going to make my life a lot easier. Is equal to 0. Because right here I'll get minus 30. And that'll make minus 52. Like that. And now I've got a is equal to 1.5. B is equal to negative 52.5. And C is equal to negative 104.50. So now my possible two answers are this. And I don't know if I got the price right. We can verify it in a bit. And obviously you can't have a negative price. So this one's excluded. And then we just got to go back to the original question. And right away I think I got this wrong because I don't think it's going to be an odd. I don't think it's going to be an odd number like that. So I don't think I got it right. So I would be tempted to do it again. So price 1 times x is going to be equal to 300. And price 2 times x minus 15 is going to yield a 330 profit. And we know that a price 2 minus price 1 is equal to $1.50, or price 2 is equal to $1.50 plus P1, which means I can replace P2 with this in brackets. Right, and then up top, it's also clear that P1 can be replaced by 300 divided by x. So let's just try it this way first. So that means 300 divided by x can go right here. All right, let's try that again. Now it was $1.50. Oh. Okay, let's just multiply it out like this and see what happens. So $1.50 times x, I get that. Minus 15 times 1.5, I get minus 22.5. Plus 300x times x, there we go, I get plus 300, and then minus 450 is equal to 300. That's a lot, is equal to 330. That's actually a lot easier to deal with. So right here, this is minus 450, well, minus 150, minus 150. Let's put it to the other side. That's plus 480. And then let's add 480. Then let's add 20. I get 502.5 is equal to 1.5x. So x, which is the number of comics, number of comics, is equal to this. So let's see what 502.5 divided by 335. So he has 335 comics, which means the second batch is 320. And if 335 times x, or times price 1, is equal to 300, we can figure out price 1. Price 1 is 300 divided by 335. Let's see if this is true. So he bought them all for 89.5 cents. And then according to this, if, did I get that? See if I maybe wrote too much. 835. Yeah, 335 times price 1. And, oh, I forgot what my x is. Doesn't matter. I've got it right there. So x is equal to, it's probably still in my calculator too. Yeah. 300 times 335. What happens? 300. And 502.5. 502.5 divided by 1.5. 335 is the number of comics. Right, okay. And then, according to this calculation, 320 times price 2 should be 330. Therefore, price 2 is 330 divided by 320. We'll see if that's a $1.50 difference. It doesn't look like it is. So again, another error somewhere. Oh yeah, $1.03. That's not a $1.50 difference. So there's a weird discrepancy somewhere that I'm probably, it depends what they mean by profit of $1.50 on each one. I assume that would be P1 minus P2, but you know what? I bet you it's not, because P2 is selling a smaller amount. I'll have to redo that one and see. It's just, that's the basic idea. I'm sure I've made a basic mistake in it. Okay, here's just a reciprocal function again for pond. So let's pretend here for a second, before we even read the question. Let's look at this formula. What happens as time gets huge? What happens as time gets 1,000,000? Well, when time gets 1,000,000, we're going to get 9 minus 90,000 times 1 over 3,010,000. Well, 1 over 3,010,000 is very close to 0. Like, it's very close. At the bigger that denominator gets, the closer it becomes. Let's just do 3 million to make our life easy. Very, very small. When I multiply that by 90,000, that 90,000 still stays very small. So as you can see, as time goes on, this entire right side of the formula becomes pretty much 0, which means we're approaching 9. So you can expect the thing to go up like that. You can also look at what happens at time 0. So at time 0, you're going to have 0 here. You're going to have 90,000 divided by 10,000, which is 9. You're going to get 9 minus 9. So at time 0, we're going through 0, 0. And it's going to rush up like this and then climb and climb and climb and try to reach 9, but never reach it. So that's the answer to B. It'll approach 9 but never reach it. And remember that it's 9, right here, C is measured in 9 kilograms per cubic meter. So we're going to approach a pollution of 9 kilograms per cubic meters. Here they ask us specifically what happens when the pollution is 6. Well, 6 is the pollution level. You put it here, like that, and it's just a mathematical equation. You've got to multiply, so make sure that this is 3t down there. That. You're going to multiply both sides by this denominator. And keep in mind on the right side, the 9 has to multiply it too. You get 9 times that. And on this left side, the denominator is just going to disappear. So that means on the right side, we're going to get 60,000 plus 18t is equal to 90,000 plus 3t minus 90,000. So those 90,000s disappear. Oh, 9 times t is going to be 27t, and it's going to be minus 9,000. So it's going to be like that. When I bring the 18t over, we've got 9t. And when I divide both sides by 9, I get 60,000 divided by 9. I get 6666666. So that's 666 minutes. You divide that by 60. And that's how many hours? 111 hours. And this is how many days? 4.62 days. Great. So that's the answer to that one. Now 13 is very similar. 13 is a production question. And I know it's hard to think of production, but here, look at it this way. If you take 4 hours to do something, and I take 2 hours to do the same thing, and we work together on the same thing, it's clear that we're going to do it a little bit better. You'd think it's 4 plus 2 divided by 2, 3 hours it's going to take us. But no, if this guy can do it in 2 hours and you're adding your labor to that, it's actually going to lower the 2 hours. So if I look at how long it's, let's say it takes me 4 hours to do something, and it takes you 2 hours to do something, and the question is how long will it take us to do it? So it'll be times t. It's going to be this, we're going to get one task accomplished. So I multiply by 4, and here I get 1 plus 2, so I get 3. So I get 3t, and if I multiply by 4 on both sides, I have to multiply 4 on the right side, I get 4, and its t is equal to 4 divided by 3. In other words, it's going to take us 1 hour and a third to do what it took this guy 2 hours if I add my help in, which makes sense because I'm not as fast as him is, so I'm going to only chip a little bit off his 2 hours. Well, it's the same thing in here, and interestingly, we don't need all 3 of them, so I don't know why they give us. Since Tom is equal to S, he gets it done in S, and Paco can do it in S minus 2. When we work together, we will accomplish the task. So it's 1 over S plus as Paco's 1 over S minus 2. Now keep in mind, this is in minutes, so we might want to convert this minus 2 to seconds because it's going to be easier, because we get the task, this time they tell us we get the task done, Tom and Paco get the task done in 1 minute and 60 seconds, which is 80 seconds, and we get one task done. So it's a lot easier to do it like that. So it's going to be 80 through this bracket, here and here, it's going to disappear. And now the secret is we have to multiply by S and S minus 20 on left and right. So I'm going to be left with 80 times S minus 120 here because the S's cancel out. And I'm going to be left with 80S here because the S minus 20 cancels out. And on the right, I'm going to be left with S times S minus 120, like this. Go ahead and do it if you want. Multiply both sides by S and S minus 20. Over here, I got 80S minus, what's 8 times that? 9,600. Like that, plus 80S. And over here, I've got S squared minus 120S. Now, now we just got to solve. We got to put all the, we got 160S here if I've done it correctly. And we got to put that to the other side. So you get 280S. And I got to add 9,600 is equal to 0. So then I've got 1 for A, minus 280 for S, for B rather, and 9200 if I did the math correctly for C. And I calculate it. No, I did it wrong. So it's saying an odd number. So I did some of the basic numbers wrong somewhere. Probably 80, but just do the algebra of this. Use your quadratic equation. This is the correct formula. It's 1 over S plus 1 over S minus 120, close brackets, times 80 seconds is going to be equal to 1. And just solve. So sorry I got all the math wrong, but I'm trying to get these done quickly now that you need them quick.